Hello, brilliant calculus students. So today we're going to learn why I'm not an art major uh, in the form of volumes of rotation. So we have a beautiful graph right here. This is exactly why I'm not an art major, but we have a sketch of the graph of y equals x squared. It's just a sketch. It looks something like this. It's a parabolic shape. So what exactly is an integral? Let's start there. Okay, so we have some tiny rectangle. I'll do this in a different color. I'll do this in green. So we have some tiny rectangle and we want to basically calculate the area of this area right here. So this is at some y value and this is a dx. We can calculate this area of this tiny rectangle here by just saying multiplying this y value by dx. And so what we can do is we can rotate this. We can rotate this about some axis. Today we're going to do the x-axis and maybe later the y-axis. And in the future, we're going to rotate this about some other axis. So this is a incredible sketch that we have here. If we rotated this about the x-axis, I'll do a little rotation symbol. So we have a little rotate arrow. So we're rotating this green piece, the singular disk, around the x-axis here. So at this point we would have a ring. As you can see, I am not an art major. Oh, we would have a ring around this singular rectangle. And we could have some, and it's going to have a thickness of dx. But we have this ring here. And so we know how to calculate the area of a ring. The area is just, the area of a ring is just pi times the radius squared. We know this because we've passed geometry. We're in calculus at this point. We know we can figure out the area of a circle. So this R, draw it in this direction. This R is the function x. That is y. That is our y value. That is x squared. This is y. So let me draw a beautiful arrow. This is y. This is our y value. So what we could really do is we could say this little area of the circle is just pi times y squared. Y is our little radius here. And we know what y is in this case. It's actually x squared. We are rotating about the x-axis, so we can do this in terms of x. So we want this to actually be pi times x squared squared. So this is our area, but we want to some of the tiny, tiny, tiny volumes. This is a really small volume. So we're actually going to calculate the volumes. And so the volumes would be pi times x to the fourth. I'm just adding these exponents here. x to the fourth, and then we also have to multiply it by the thickness of the ring. So the thickness of the ring is just dx. So to add up all of these tiny volumes, we integrate this. And we're going to go from 0 to 2 in this case. 0 to 2. And we can pull out our pi, and we can do this integral. We can do the definite integral of 0 to 2 of x squared to the fourth dx. We can do this integral. So if you wanted to kind of see what this would look like, kind of imagine this, if you will, we'll have a big circle here, kind of going through my math. And then we're going to kind of just go up here, and then we can, because every single point is being rotated around. So let's not do that as a dotted line. I'll also do this as a yellow or something. So we could just say it's like this. It's gonna be, and then we could kind of shade it if we wanted to. It's going to be a cone type of thing. So I'm gonna just erase all of this and draw it separately, as to not ruin my math over here. So I'm gonna just draw this one more time. So we have our little graph, and then we're going to have our ring about a radius, and then we're going to connect it. I don't know what that is. It's like that. There we go. It's gonna look something like that, and this is why I'm not an art major. But what if we had the exact same function, but we wanted to rotate it around the y-axis? So we have our x-axis here, and we have our y-axis. And so we will have our function x squared y is equal to x squared. I don't know what I'm writing there. Y is equal to x squared. And we want to instead rotate this about the y-axis. So how would we go about doing that? First, let's try and imagine what this would look like. So we could imagine this circle type of thing. It looks like a kind of a little cup. And then we could imagine a tiny rectangle right here with a thickness, and keep note that this is actually a tiny thickness in the y direction. So this is a dy. And what is this height? This height is our x value. The height of the rectangle in this direction is actually our x value. So if we want to rotate it about the y-axis, we have to do everything and find x as a function of y. But we can then find a tiny ring, like before, find the volume of a tiny ring, and integrate over that interval. So how do we find this x first of all? We don't have x, we just have our thing in terms of y. So let's solve for x real quick. Taking the square root of both sides, we get y is equal to, the square root of y is equal to x. Well, that was easy enough. We now have our y. And let's just say the y value we want here is 4. Because we did 2 over here, this is actually at the point 0.24. So let us integrate now. We know that the area is equal to pi r squared. The area of a singular slice is equal to pi r squared. We are brilliant geometry students. In fact, we are brilliant calculus students who have passed geometry. And r, what did we figure out r was? R is Rx. So the area is actually, the area is pi times x squared. We're looking in the x direction, and we're rotating about the y-axis. So this is actually pi times x squared. What is x? Square root of y. So pi times the square root of y squared. Well, that's kind of useful because this squared and square root cancel. They undo each other. They are inverse operations, as the cool kids say. So this new area is pi times y. But we want to find the volume of this sphere so that we can just sum up the tiny volumes. So how do we do that? We say the volume is the area times the little height, which is dy. So volume is pi times y dy. And so if we wanted to find the volume total, the total volume, V total, because this is the volume of a singular ring, the total volume would have to integrate from 0 to 4. And then we're just going to pull out a pi because it is indeed a constant coefficient here. We could just say y dy. And again, we can integrate this because we are brilliant calculus students. We can just use our power rule. But that is it for rotating about the x and y axis.